All right, let's break this down from first principles. First, there was Oumuamua, a weird object, oddly shaped, accelerating for no visible reason. Avi Loeb from Harvard, a smart guy, said, "Hey, what if this is technology?" And what did the scientific community do? They laughed him out of the room. Glory hound? Fantasist? A huge mistake. Shutting down debate when the data doesn't fit. That's anti-science. We missed the first wake-up call. It just flew away. And now, a few years later, a second one shows up. Try Atlas. And this time, it's much more obvious. The signal it's sending isn't radio. It's chemistry. Pure, undeniable chemistry. See? The universe has rules. Cosmic manufacturing, if you will. When a supernova explodes, it forges heavy elements. And it always forges iron and nickel together. Always. It's like a software code. They're an inseparable pair. Every asteroid in our system follows this rule. It's physics. But Tri-Atlas breaks that code. Our telescopes see it venting pure nickel with no iron. That shouldn't happen. It's like finding a human skeleton with no calcium. It's fundamentally wrong. And here's the kicker. Where in the known universe does nickel exist without iron? Only one place. Right here. On Earth. In our factories. When we create high-tech alloys, like shape memory alloys, nickel titanium for the aerospace industry, what do we get as a byproduct? Pure nickel, without iron. A one-to-one match for what we're seeing out there. So, let's drop the metaphors. We're not looking at a rock. We're looking at an exhaust plume, an industrial process. This isn't a matter of belief. It's a matter of data. And the data says we are looking at a machine disguised as a comet. Or maybe this is just its normal operating mode. And the question now isn't, what is it? But what is it doing in our solar system? This isn't just a science puzzle. This is possibly the most important existential question humanity has ever faced. And we'd better find an answer. Fast. For centuries, humanity looked at the sky and saw a cosmos that was indifferent, governed by blind, eternal physical laws. Everything could be explained through gravity, thermodynamics, and nuclear fusion. But now, something has arrived that seems to shatter that view. It carries the fingerprint of intention, the mark of engineering, the possibility that we are not alone, and that someone, somewhere, is using tools far more advanced than ours. This discovery is causing a deep rift. Because if an object disguised as a comet is here, shedding industrial waste, it means it's not just randomly passing through the solar system. It's likely performing a function. It might have a purpose, and that's where the conflict intensifies. Scientists are trained to reject extraordinary hypotheses until all ordinary explanations are exhausted. But all the ordinary explanations have failed. Iron and nickel are inseparable in nature. All that's left is to accept the impossible. Tri-Atlas is not a geological phenomenon, it's a technological artifact. Avi Loeb, once ridiculed for suggesting Oumuamua could be artificial, is now seeing his warning take shape. He argued that the universe could be filled with interstellar probes disguised as common rocks, slipping into solar systems without raising suspicion. At the time, it sounded like cheap sci-fi. Today, faced with Tri-Atlas, it sounds like a prophecy. And it's not just about the nickel. Other signs are starting to appear, painting an even more disturbing picture. But even before we get to those, this first piece of evidence is enough to signal a breakthrough. The simple realization that a piece of space metal is a byproduct of engineering, not nature. This isn't just about analyzing a comet. It's about rethinking our own place in the universe. Are we the discoverers or the discovered? Are we the observers or the observed? Because if this object is truly a machine, it's not here to just exist. It's here to function. And this is just the tip of the anomaly. The pure nickel was only the first sign. What comes next challenges the laws of nature even more and unveils a secret that could turn a simple comet into the most sophisticated disguise ever found in space. Imagine you light your stove at home and see the blue flame burning gas. Now imagine looking up at the sky and realizing an interstellar object is doing something similar, breathing out gases with a precision that looks more like a controlled process than a natural event. That's the scenario unfolding with Tri-Atlas. We're no longer talking just about the chemical anomaly of nickel, but a collection of signs that, when put together, create a baffling picture. The picture of an object that breathes like a machine. The James Webb Space Telescope determined that the atmosphere surrounding this visitor is nothing like a normal comet's. Typically, when the sun heats the ice on these bodies, the result is predictable. Lots of water vapor, long bright tails streaking through space, and gases like carbon monoxide. It's a familiar, almost routine sight for astronomers. Tri-Atlas has shattered those expectations. Its coma is 95% carbon dioxide and only 5% water. Water, the cornerstone of any comet, is virtually absent. Even stranger, carbon monoxide, which is almost always present, is completely missing. And as if that weren't enough, an unexpected signature appears. Cyanide, a toxic compound used by humanity in metallurgy for polishing, plating, and treating metal surfaces. It's like finding sawdust in a forest with no carpenters. This combination, the dominance of carbon dioxide, the absence of carbon monoxide, the presence of cyanide, and of course, the pure nickel, isn't a cosmic accident. It's a pattern that looks more like an industrial production line than a natural body. In science, patterns are everything. When Galileo pointed his telescope at Jupiter and saw 4 little dots orbiting it, it wasn't just a pretty sight. It was an orbital pattern that disproved centuries of geocentric beliefs. Now, with Tri-Atlas, the chemical patterns are screaming that something is wrong. The direct implication is obvious. If we admit the data cannot be explained by known natural processes, we have to consider that we're facing extraterrestrial engineering. No more speculation, no more philosophical hypotheses, but concrete evidence, proof that somewhere in the cosmos, intelligent beings exist who can manipulate matter on an interstellar scale. Accepting this would be a revolution on par with Copernicus or Darwin. Copernicus moved us from the center of the universe. Darwin knocked us off the pedestal of divine creation. And now, Tri-Atlas might strip away our illusion of being alone. But what does this mean outside of the lab? What changes for the person who rides the subway every day, pays their bills, and lives seemingly far from telescopes? Everything. If this object is truly artificial, it directly impacts our sense of security, our technology, and even the future of our species. Think about the advancements the mere idea of alien engineering could bring. When the Wright brothers flew for just 12 seconds in 1903, no one could have foreseen that we'd be walking on the moon 66 years later. Now imagine the leap forward when we realize that advanced civilizations not only exist, but are already launching machines beyond their own systems. It would force us to rethink all of our engineering, from the smartphones in our pockets to the jet turbines in the sky. And here's a crucial detail. Nickel separated from iron isn't just waste. It's the signature of high-performance metal alloys, so-called shape memory alloys, capable of returning to their original form even after extreme deformation. These materials are used in aviation, medicine, satellites, and even space robots. To see this chemistry in interstellar space is like finding an engineer's manual printed in the cosmic dark. But above all, this object exposes human discomfort. We, who for centuries considered ourselves the pinnacle of creation, or at least the only known example of intelligence, are now forced to admit we might be just a small chapter in a much larger story. This is both awe-inspiring and terrifying. It's the same fear we've felt before. When the first X-rays showed bones beneath the skin, many thought we were violating the secrets of the body. With the advent of nuclear power, the world was torn between the promise of infinite energy and the horror of atomic annihilation. Now, with Tri-Atlas, we feel that same chill down our spine. We are facing something that could be beautifully inspiring or dangerously threatening. In essence, this object is also a mirror. It shows us how prepared or unprepared we are to face the unknown. It highlights our tendency to reject what we don't understand and to scorn ideas that challenge our comfort zone. Avi Loeb was mocked for years for defending the possibility of interstellar probes disguised as rocks. Today, with the evidence at hand, his voice sounds much louder. And that's an important lesson. How often in our daily lives do we ignore signs because they seem too unlikely? How many times have we dismissed opportunities, ideas, or changes because they didn't fit into what we thought was possible? Tri-Atlas is both an astronomical discovery and a metaphor for life. Ignoring the impossible doesn't make it any less real. If we accept that there is hidden engineering in this disguised comet, our perception of the universe will change forever. And this change isn't abstract. It's practical. From that moment on, every telescope, every space mission, every scientific debate will be shaped by a new question. What else is hiding in plain sight? This could redefine technological investments, spark geopolitical struggles to control the first evidence of intelligent life, and even alter our collective psychology. We've seen this on a smaller scale when the first image of a black hole was published in 2019. Millions of people who had never read a science paper shared that photo because they felt they were seeing something bigger than themselves. Now imagine that effect multiplied by the certainty that an alien craft might be right in front of us. It wouldn't just be news, it would be a turning point. That's why following every step of this investigation isn't just curiosity. It's witnessing the birth of a new worldview. We are at a moment where science and philosophy meet, where questions about the cosmos intertwine with questions about who we are. If you're here watching this, you're already part of this journey. With every new piece of data, every new analysis, we are putting together a puzzle that could redefine human history. So, I invite you. Subscribe to the channel, turn on notifications, and follow every update on the mystery of Tri-Atlas, because it's no exaggeration to say that what we discover about it could change not just astronomy, but the destiny of our species. And then, something even more disturbing happens. Tri-Atlas is not just breathing strange gases. It's behaving contrary to the laws of physics, moving dust and matter in a way no natural comet ever has. For centuries, astronomy has been based on a simple principle. Nature is consistent. For example, comets follow a predictable script. As they approach the sun, they heat up, their ice sublimates, and they form long, glowing tails that stream away from the star, pushed by radiation pressure. This behavior is so well understood it's almost a cultural law. When we think of a comet, we picture its bright tail streaking across the sky. Tri-Atlas doesn't behave like that. Since its discovery, astronomers noticed something deeply unsettling. The dust cloud surrounding the object wasn't being pushed back, as the sun's physics demands. Instead, it seemed to be pushed forward, as if propelled by an invisible force. For months, this pattern repeated without any plausible explanation. There was no solar wind capable of reversing this dynamic, no nearby gravitational fields to explain the anomaly. It was as if the dust was being actively propelled, defying the very foundations of celestial mechanics. What force could manipulate matter this way? At first, some tried to offer conservative interpretations. Could instrumental errors have skewed the data? But multiple independent observatories confirmed the phenomenon. Could it be a poorly understood physical property of certain compounds? Chemical analysis of the ejected material didn't support that hypothesis. That left the most unsettling explanation. Some kind of mechanism was actively moving the dust. This is where the first philosophical break occurs. We've always considered the laws of physics to be immutable and universal. But when faced with Tri-Atlas, the question changes. The problem might not be with the physics, but with the presence of volition. If the dust isn't obeying the known laws of nature, could it be that it's being controlled by the object's internal systems? The calculations of the amount of nickel ejected along its trajectory add to the strangeness. It's estimated that the object has already ejected 1/2 ton of pure nickel, and its ejection rate is increasing as it gets closer to the sun. On an industrial scale, this volume of waste would correspond to the production of about 50 kilograms of high-strength metal alloys. Why would a celestial body be selectively ejecting the equivalent of a factory's byproduct? It's becoming harder and harder for astronomy experts to maintain the natural hypothesis. The lack of iron, the presence of cyanide, and now the dynamics of the dust paint an uncomfortable picture. A body that behaves more like an active system than a passive rock. The Caltech astrophysicist Konstantin Batygin, commenting on similar anomalies in Oumuamua, stressed that the absence of solid natural explanations doesn't confirm technology, but it requires us to face the data without dismissing it as statistical noise. That sentence is a warning. There's a line between scientific prudence and systematically denying the evidence. If we can't fit this phenomenon into our existing models, what's left? One hypothesis being discussed is that Tri-Atlas might be actively using the space environment, much like a sailboat uses the wind. Advanced machines could manipulate electromagnetic fields to redirect particles around themselves. This would explain why the dust appears to be moving in the opposite direction predicted. It's not a natural, uncontrolled tail. This idea connects to concepts being explored in space engineering. NASA and ESA have already tested so-called ion propulsion, where charged particles are accelerated by electric fields to create continuous thrust. While our technology is still in its infancy, it's plausible that more advanced civilizations could have mastered far more sophisticated versions of this mechanism. If we're already using particles as fuel in our experiments, why couldn't another, much older and more advanced system do the same on a cosmic scale? But the discomfort doesn't end there. When Tri-Atlas finally did develop a dust tail, it was incredibly short and faint compared to what was expected. Its brightness didn't match the volume of gases and particles detected. To many astronomers, it looked more like a trash trail than a comet's tail. It was like watching a quiet factory polluting its environment rather than a natural phenomenon releasing abundant vapor. What is being produced there? Scientific reasoning requires caution. It's not about jumping to conclusions about hidden machinery. But ignoring the complexity of the data isn't science either. The key is to formulate consistent hypotheses. Some researchers suggest that internal radioactive processes could generate enough heat to keep the object active at great distances from the sun, without relying on stellar radiation. This would explain the early gas release, but it doesn't explain the lack of iron or the dust structure. At what point do we stop forcing natural models to explain something that persistently behaves outside the rules? The scientific community is divided. On one side are those who defend conservative explanations, however fragile they may be. On the other are those who admit that the data points to something beyond our current understanding. This stalemate has happened before. Galileo faced similar resistance when he described moons orbiting Jupiter. Darwin was attacked for proposing natural selection. In both cases, reality eventually won out, not because of faith, but because of the data. Are we on the cusp of another historic turning point? The next few months will be crucial. Tri-Atlas is approaching its perihelion. Telescopes will gather even more precise data. James Webb, Hubble, and even the newly inaugurated Vera C. Rubin Observatory are watching this guest closely. The behavior of its tail, its gas release rate, and its chemical composition are expected to become even clearer. And with clarity comes responsibility, to interpret without reducing the complex to the trivial. Are we prepared to face conclusions that might not be comforting, but could change our worldview? Because if all this points to an active system, a deeper question remains. Tri-Atlas wouldn't just be reacting to its environment, it could be operating with a purpose. And it is this idea that paves the way for one of the most unsettling hypotheses in modern astrophysics. When the first calculations about Tri-Atlas began circulating in technical reports, one hypothesis resurfaced. An old idea, discussed in closed-door conferences and in papers often relegated to the speculative fringe of astrophysics: self-replicating probes. Known as von Neumann probes, named after the Hungarian mathematician John von Neumann, these machines would be designed to travel between star systems, gather raw materials, create copies of themselves, and launch those copies on new cosmic routes. A slow but relentless process, capable of colonizing an entire galaxy without a single biological being on board. For decades, this idea was considered just a theoretical exercise, but the data from Tri-Atlas has suddenly made it more plausible. Not because it directly confirms these probes exist, but because the observed pattern, the dust accumulation, the selective ejection of metallic residue, the activity in regions too cold to be explained by solar heating, matches frighteningly well with what scientists themselves imagine for such a machine. In 2008, astronomers observed an unprecedented event. A young star 450 light-years from Earth, known as TC 824-12652, lost nearly its entire protoplanetary disk in just 2 years. This disk is essential for forming planets, a cloud of dust and rock that slowly coalesces into worlds. The sudden disappearance of this material, the equivalent of 102 kilograms of matter vanishing in the blink of an eye, was never explained. Theories from extreme radiation to gravitational events were proposed, but none fit the facts. The case was filed away as an unresolved anomaly. However, in light of hypotheses about matter harvesting machines, it takes on a new dimension. What if the disk's disappearance wasn't caused by natural forces, but by the intervention of systems capable of processing large volumes of stellar dust in a short time? It's an uncomfortable thought, but to dismiss the coincidence is intellectual laziness. How many times in the history of science have ignored or poorly explained phenomena turned out to be the key to something bigger? There's another often overlooked statistic. The physicist Frank Tipler estimated that if self-replicating probes were possible, it would take only 10 million years to colonize the entire Milky Way. That's a cosmic blink of an eye, less than 0.1% of the galaxy's age. Tipler used this logic to propose a radical version of the Fermi paradox. If we don't see evidence of these machines, it's because they don't exist. But the reasoning can be flipped. If we are observing signals that fit the profile, then we've already moved beyond theory and into detection. It's this inversion of perspective that makes Tri-Atlas so unsettling, because it's no longer about imagining a remote possibility, but about facing data that resembles a technical manual turned into astronomical behavior. Perhaps we are seeing the first concrete evidence of what the statistics have always considered inevitable. The idea of space machines has appeared countless times in science fiction. From 2001, A Space Odyssey to Star Trek, probes have been portrayed as mysterious or threatening entities, often reduced to metaphors for our fear of technology. However, this cultural layer eventually became an obstacle to serious discussion. For years, any scientist who dared to mention self-replicating probes was accused of thinking like a science fiction writer instead of a researcher. The result was predictable. The topic was sidelined, cited in footnotes, rarely taken seriously at prestigious conferences. But the cosmos doesn't care about scientists' reputations. The cosmos acts. And now, in the face of Tri-Atlas, the line separating fiction from concrete data is beginning to blur. How many other phenomena were ridiculed as tall tales until the instruments revealed an uncomfortable reality? Some recent studies also point to unaccounted for patterns. A 2019 paper in the astrophysical journal Letters analyzed the disappearance of dust clouds around young stars. The official conclusion was ambiguous, possibly due to poorly understood natural processes. That phrase, while scientifically honest, served as a seal of silence. Few delved deeper. Today, rereading those lines in light of Tri-Atlas's behavior, what once seemed poorly understood begins to sound like strategically avoided. After all, science is done by humans, and humans are afraid of drawing conclusions when the facts seem bigger than they can imagine. Perhaps we are facing another case where academic caution has turned into willful blindness. At this point, we've gathered three distinct layers. The anomalous behavior of Tri-Atlas, inconsistent with natural comets. The sudden disappearance of protoplanetary disks in young systems, a documented but never explained phenomenon. And the statistics that show self-replicating probes could colonize an entire galaxy in less time than Earth's own history. Separately, each of these elements is uncomfortable, but together, they form a mosaic that resembles a pattern. If isolated phenomena on different scales are pointing in the same direction, to what extent can we continue to consider them coincidences? Accepting this hypothesis is not just a scientific challenge, but an existential one. The question is not just whether intelligent life exists beyond Earth. The question is, are we already within the sphere of influence of intelligences we don't see directly, but whose footprints we are beginning to feel? This possibility forces us to rethink not just astronomy, but politics, economics, and technology. In the 20th century, the mere suspicion that the Soviet Union could put satellites in orbit triggered the space race. Now, imagine the psychological, strategic, and cultural consequences of realizing that the solar system might already be on the path of self-replicating machines of unknown origin. What would it mean for our confidence as a civilization to realize that we don't even control who is circulating in our own cosmic backyard? In short, what we're seeing in Tri-Atlas isn't just an anomaly. It's possibly the final piece of a puzzle that science has been avoiding for decades. Reports were ignored, statistics were interpreted selectively, cases were dismissed as fiction. Now, it's all coming back with a vengeance. And the most interesting part is realizing how we've always been inclined to downplay this evidence, as if we have an instinctive resistance to accepting that the cosmos might be more active than we'd like. Why do we prefer to live with weak hypotheses rather than face uncomfortable explanations? Because if Tri-Atlas does in fact fit the pattern of a harvesting probe, then it's not just a random occurrence. It might be a response to what we have already done, to the signals we have been sending into space for the last century. And that's when the story stops being just about science and starts being about us. A little over a century ago, Earth was a silent sphere lost in the vacuum. Not a sound escaped, not a single signal crossed the heavens. But in 1936, something changed. The broadcast of the Berlin Olympics became one of the first signals strong enough to escape our atmosphere and travel into space. Since then, radio waves, television, and more recently, digital communications have turned the planet into a beacon. Whether we like it or not, we began announcing our presence to the cosmos. In the 1970s, human audacity went beyond accidental leaks. The famous Arecibo message, transmitted in 1974 towards the M13 star cluster, was a deliberate declaration of who we are. It contained information about our DNA, our solar system, and even a silhouette of a human. Other messages followed, like the Cosmic Call designs in 1999 and 2003, and the Teenage Message broadcast from Ukraine in 2001. These were gestures of trust, of hope, but also of naivety. We were waving into the unknown, without considering what kind of response it might provoke. And now, in the face of Tri-Atlas, the question carries weight. Was the cosmic silence broken, and has a reply been received? We're used to thinking that space is indifferent, that our signals dissipate into the noise of the universe. But that view ignores a crucial point. math. The speed of light is finite, but relentless. The first radio signals sent from Earth have already traveled about 100 light years, covering thousands of stars in their range. On a cosmic scale, we have sent a scream that has pierced our stellar neighborhood. If any civilization in that sphere had adequate instruments, they would have already heard us. Worse, not only would they have heard us, but they could have identified the artificiality of our signals, distinguished the patterns, and recognized their unnaturalness. Just as we identified nickel separated from iron as proof of engineering, others could recognize the digital signatures of our signals as proof of technology. To ignore this possibility is to choose naivety. If Tri-Atlas is indeed a response, then we are facing a disturbing inversion. For decades, we projected the desire to find others. Now the equation is flipped. We are not just the seekers, but also the sought. And this confronts us with a civilizational dilemma. What does it mean to be the focus of something we don't understand? On a personal level, this touches the roots of our identity. We were raised on narratives that put us at the center, as the chosen species, a unique consciousness, the pinnacle of evolution. But faced with the possibility that self-replicating machines are already circulating among the stars, we find that our centrality may just be a convenient myth. From a scientific perspective, the consequences are devastating. Many models we use to describe the cosmos, from planet formation to the probability of life, were built on the absence of evidence for advanced civilizations. If Tri-Atlas is confirmed as an artifact, it would undermine those foundations. It would force science to start over, to admit that the universe might be far more populated, active, and technological than we imagined. And on a civilizational level, the issue is strategic. Just as the 20th century space race was driven by the fear of a rival power seizing the high ground of orbit, we now face the possibility that the human race itself is at a disadvantage on a cosmic scale. So let's recap. An interstellar object is ejecting chemical residue impossible in nature, but common in human industry. Its dynamics defy known laws, as if it were actively manipulating matter. Past astronomical cases, like the disappearance of protoplanetary disks, already pointed to anomalous phenomena, but were filed away as unexplained. And this moment coincides with a century of broadcasts that humanity has been beaming into space. The picture isn't comforting, but ignoring these connections isn't science. It's fear. Denial doesn't make the problem go away. When humanity was slow to recognize the risks of climate change, it wasted precious decades in fruitless debates. When we ignored early warnings about pandemics, we paid with lives and global instability. The same applies here. Denying an anomaly doesn't make it less real. On the contrary, it only makes us more vulnerable. The risk is not just scientific, but cultural. If we accept Tri-Atlas as just another comet, if we don't investigate it thoroughly, we not only miss the chance to understand something extraordinary, but we also reinforce a pattern of collective complacency. We prefer the comfort of normalcy to the discomfort of the truth. How many times in our daily lives do we repeat the same mistake? How many times do we miss the clear signs of a failing relationship, a collapsing system, or an emerging opportunity, simply because addressing them would require a transformation? But we also have to face the other side. Accepting that Tri-Atlas could be more than just a comet takes courage. This understanding opens doors, but it also imposes responsibility. It demands a less arrogant and more open science, a less short-sighted and more forward-thinking politics, a less distracted and more aware society. Understanding doesn't guarantee comfort, but it does provide preparation. Imagine the psychological and technological consequences of accepting that we are not alone. History shows that major shocks bring both chaos and progress. When Columbus arrived in the Americas, civilizations were destroyed, but a global leap in cultural and economic interaction also occurred. When the atom was harnessed, we saw Hiroshima, but also nuclear reactors generating power. The same applies here. Acknowledging the presence of alien technology in the solar system would be a shock, but also an opportunity for unprecedented cognitive expansion. In the end, there is no easy answer. Denial is dangerous, understanding is frightening, but pretending to be neutral is impossible. Triatlas has already made its mark. It has already exposed contradictions we cannot ignore. It forces us to recognize that we are being challenged not just as scientists or governments, but as a species. The question that remains is not what Triatlas is, but how we will react to what it represents. And that's why your presence here matters. This isn't just about astronomy or far-fetched hypotheses. It's about our relationship with the unknown, about how we react to signals that don't fit our expectations, about the courage to look up and admit that the universe might be much bigger, more active, and more complex than we ever imagined. So I invite you, subscribe to the channel, turn on notifications, and like this video. By doing so, you won't just follow every new discovery, but you'll also create a space for reflection where we can, together, face the questions that define us as humanity. And don't forget to leave a comment with what you think. Triatlas. Are we looking at a common comet, or proof that we have already been found? The universe was never silent. We just didn't know how to listen. Now that the signs are in front of us, the most unsettling question remains. Are we ready to handle the answer?